Okay, so rationalizing the denominator is a very easy concept to understand, and I'm going to kind of show you how it works. Okay, what is the square root of 9? 3. Okay. What if I did this? What if I took that 3 and made it into a square root of 3, and then I squared it? What would the answer to that be?
9. 3.
What happens when you have your square root and your square? What do they do to each other? They can't. They're inverses, right? They cancel each other out. So this is actually the answer to this is actually what?
3.
3. Okay. Or I could have written this another way, right? I could have written it as the square root of 3 times the square root of 3, right? There's 2 of them. And what would my answer have been? 3. Okay. Rationalizing the denominator. We use this concept to rationalize, okay? Because they say you cannot have a radical in the denominator. So if you have a radical in the denominator, the way you get rid of it is you multiply it by itself, okay? Because if I have a square root of 3 in the denominator and I multiply it by itself, when we get our answer, there's no radical anymore, right? So that's kind of how we do these. Let's take a look at this first one here. We have the square root of 15 over the, square root of 15 over 2. So we would have to go in and split it up. So we would have the square root of 15 over the square root of 2. And here's the problem. We have a square root of 2 in the denominator. But I can apply this same method that I did with the square root of 3 over here. So if I multiply top and bottom by square root of 2, I multiply top and bottom because what? Because this is one of what we call those special ones. Because square root of 2 over square root of 2 still will equal 1, right? And so in the numerator, what would we get? The square root of 15 times the square root of 2 is what? Square root of 30. And now, when I multiply a square root of 2 times the square root of 2, what do I get?
2.
You get the 2. Okay, so it works just like this up here.
So,
Okay, let's look at our second example. We have 3 over the square root of 5. Well, we cannot have that radical in the denominator, so we're going to use our process here to get rid of it. So what am I going to multiply with this fraction here? Square root of 5. And remember, what you do in the denominator, you also do in the numerator. So what would that give us in our numerator now? Mm-mm.
square root of 15.
Mm-mm.
15.
Mm-mm.
3 times the square root of 5.
3 times the square root of 5.
Oh,
Oh, I thought that's what you said. Over square root of 5 times square root of 5 is 5.
I heard you said denominator.
Oh. Sorry. Do you see the difference in these two? Up here, the 15 was under the radical, right? So I could multiply those together because those were both radicals, right? Down here, that was not the case, right? 3 is a whole number, whereas you have this radical here. That's why I was trying to get you guys into the habit the other day. How do we say this? We say this 3 times the square root of 5. So you keep that connection.
First one, if 2 times the square root of 2 times the square root of 2 equals 2, then minus the square root of 15 times the square root of 2 equals square root of 30.
It is. That's what that is.
So I'm just asking on the bottom, why is it not a square root, but it's not a square root?
Because you rationalized it. If you take the square root of 2 and multiply it by the square root of 2, it's a 2. That is the process of
Yeah,
rationalizing.
I get that, but I'm asking why on the top it's a square root.
So let's take a look at this first one here, the 6 over the square root of 2. We cannot leave that square root in the denominator, so what did you multiply by? Square root of 2 on top and bottom. So that would leave you with 6 times the square root of 2 over 2. Whoops. Now, you should have learned in algebra that you have all types of numbers. Numbers can be classified. We have the realm of real numbers and we have the imaginary numbers. Okay? And you guys probably did not discuss those. Your real numbers consist of rational numbers and irrational numbers. Do you remember what the irrational numbers are?
Decimals.
They're the decimals that never end, right? So if it's got a pattern or it ends, then that's okay. So in this case, when you're looking at 6 times the square root of 2 over 2, you have the radicals are the irrationals, because this is going to be, if you put it in the calculator, and you guys know we've been doing this, you put that in the calculator, you're going to get a decimal, right? And it continues on. So that's irrational. However, the 6 and 2 are whole numbers, right? So they are rational. So when I look at this, I can do one more step with my whole numbers here. What could I do with a 6 over 2? I can go ahead and divide it, or I can simplify that out. And then if we do that, what will we have? So that would become 3. So that would be 3 times the square root of 2. And that would be your answer. Okay? All right, let's look at our second one. What? Right here? Prince, got it? Okay. Now, our second one. So we cannot leave the square root of 3. So what did you multiply with here? And what did you get in the numerator? Over 3. And that one we can't, right? We can't divide 7 by 2 or reduce. Okay, so that one you just leave.
It's 3.
Oh, it's 3. No. Thank you. And remember, this 3 and this 3, they're 2 different types of numbers, right? This is irrational, and this is a whole number. Okay, any questions on this? Before we move on. We good or not?
Oh.
Okay. We'll stop that one.